Hello and welcome to this video about theorems and proofs in linear algebra. In this video we'll prove that linear transformations and matrices are interchangeable, and that means that every matrix is a linear transformation and every linear transformation can be represented by a matrix. This theorem wasn't mentioned in the textbook, but I feel like I can prove it here. And I'd like to mention that these two things are interchangeable again. This means that they are actually the same things, but defined differently. So now to start this proof, we'll define all of these things here, and do the proof in the first direction, that every matrix is a linear transformation. So we'll define all of these variables. We'll show that matrices satisfy the two conditions necessary to be linear transformations. They firstly satisfy this addition property, and then they satisfy this multiplication property. So now we've proven the first part, that every matrix is a linear transformation. So now to prove the second part in the opposite direction, that you can find a matrix for every linear transformation, that every linear transformation can be represented by a matrix. This is really saying that every linear transformation is a matrix. So we can actually construct the matrix for a given linear transformation here. The column vectors will be the linear transformation function acting on the standard basis vectors e1 to en. And these are the standard basis vectors. They are column vectors containing zeros everywhere except in the position given by the indice of the letter e, where it's equal to 1. So we can set any column vector x that's n-dimensional to be a linear combination of these standard basis vectors e1 to en. Then we'll multiply it by the matrix A on the left. I'll just make some more room on the screen here. So we can substitute what each of these standard basis vectors are into this equation to give us this. I like to show you every step so that you'll be able to easily see that this theorem is correct. We can multiply each of these standard basis vectors by their coefficients to give us this equation. And adding all of these column vectors together gives us this column vector, which is a column vector of coefficients. Then we can substitute the matrix that we constructed in for matrix A. We can multiply it out like this, showing that each coefficient acts on each column of the matrix like this. Then we can write it out like this using function notation that can fit on one line. By a past theorem, we can collect this sum of linear transformations together into this single linear transformation, which is equal to Lx, because this linear combination of standard basis vectors is equal to x. And so we found the matrix that represents this linear transformation, that proves that it exists for every linear transformation. So we've proven this theorem, that they're interchangeable, and that they really are the same thing. So I'll just prove part 2 of this theorem again in a more compact way. We'll firstly define what matrix A is, that represents L. We'll set x to be equal to this linear combination of standard basis vectors. We'll multiply A by x like this. We can quickly manipulate this equation to be this matrix vector equation, which we can quickly manipulate again to be this linear combination of vectors. So we can collect this linear combination of linear transformation functions into a single linear transformation function using a past theorem, and this is equal to Lx. And so A and L are equal for any possible vector, so we've proven this theorem. So I hope that you found this video to be helpful and educational. Please click like and subscribe if you did. Please leave some helpful thoughts and ideas in the comments if you have any. Feel free to share this video, and thanks a lot for watching.